curvature or massive negative curvature. But astronomers discovered that the universe is flat to a very fine degree of precision. It's not curved either way, which again contradicts the Big Bang model's expectations. If you're wondering what curvature of the universe means, it's a geometrical measurement of the cosmos that astronomers use. The important thing is that the Big Bang model said that the universe would have massive curvature in one direction or another, but it doesn't. It apparently has zero curvature. Each of these problems contradicted the Big Bang's predictions, and each one presented a fatal challenge to the model. So cosmologists were relieved when in 1980, a cosmologist named Alan Guth proposed a radical new idea that is now called inflation. Inflation says that right after the Big Bang occurred, the entire universe grew explosively for a very short time. Actually, grew isn't really the right word. We're talking about the entire universe exploding in size at multiple times the speed of light. As one physicist explained, at this rate of inflation, a region of space the size of a pea would be stretched larger than the observable universe in a time interval so short that the blink of an eye would overestimate it by a factor larger than 1,000,000 billion billion billion. And it turns out that for various reasons, inflation supposedly resolves all three of the problems I just mentioned. And so, inflation is a vital part of the Big Bang model today. It's the only explanation cosmologists have found for these three fatal problems. But it turns out that inflation has failed and doesn't actually rescue the Big Bang from its problems after all. First of all, it's important to note that even if inflation were true, it still wouldn't solve the Big Bang's other problems outside of these three. For example, it doesn't help solve the problem of everything coming from nothing. As Guth himself has admitted, inflation itself takes a very small universe and produces from it a very big universe. But inflation by itself does not explain where that very small universe came from. Second, cosmologists have no explanation for how inflation could have occurred. There's nothing in physics that can explain this process. Supposedly, inflation was driven by a particle called an inflaton. But has anybody ever seen an inflaton? No. Is there any room within particle physics for an inflaton? No. Is there any justification for believing in the inflaton, or inflation overall, other than the fact that the Big Bang model needs it? No. As one physicist admitted, inflation's theoretical underpinnings may be rather tentative. The inflaton, after all, is a hypothetical field whose existence has yet to be demonstrated. And as an article in Astronomy magazine explained, what drove inflation? Nobody knows. Physicists have suggested different models to describe the inflating universe, but all the solutions are mathematical conveniences with no particular physical basis. All the theories of inflation amount to proof that we don't have one good theory yet, says this astrophysicist. So inflation is the name given for a hypothetical process that's never been observed, based on a hypothetical particle that's never been observed, and that has no basis in physics. But according to secular cosmologists, even though inflation has no basis in physics, it must have happened, because otherwise, the Big Bang model would be falsified. And we know the Big Bang model is true. See the reasoning here? Secular cosmologists often say that we know inflation happened, because otherwise the Big Bang model would have the monopole problem, the horizon problem, the flatness problem, and so on. But that's a logical fallacy. Evidence against the Big Bang model is not evidence for inflation. Overall, inflation is a belief that's driven not by good physics, or even by good logic, but merely by a desire for the Big Bang to be true. In other words, to explain away some of the fatal problems in their model, secular cosmologists are invoking something that's unknown to science, and that has no apparent basis within science. That's not a scientific explanation. That's an appeal to miracles. Now, as a Christian, I accept that the creation of the universe was a miracle, done by an omnipotent, omniscient creator. But here we see that secular cosmologists also believe in miracles, even though they claim to deny them. So far, we've seen that the Big Bang has severe problems, including, how can a universe come from nothing? How can nothing turn itself into everything? How can inflation account for anything? And so on. But along with theoretical questions like these, the Big Bang also has problems with physical evidence, things that we see in the universe. Let's talk about some of those now. First of all, there are indications that there might be some stuff in the universe that we can't see. For example, many galaxy clusters don't appear to have enough mass to hold themselves together gravitationally. When this was first discovered, Astronomers called it the missing mass problem. Another example is seen within individual galaxies, where stars move around as they orbit the galaxy's center of mass. However, in many galaxies, the outer stars are moving too quickly for the galaxies to hold themselves together over long timescales. Again, it was proposed that there's a lot of missing mass somewhere to hold them together. Most astronomers today believe that these observations indicate that there is actually mass there to hold these structures together. They believe that this mass isn't really missing because it's there. It's just that we can't see it. But if these observations were actually caused by mass that we can't see, how much of it would there be? A lot. Almost 6 times as much as the visible mass. For every galaxy you see, there would be almost 6 galaxies worth of stuff that you don't see. In other words, only 15% of all the physical stuff in the universe would be visible to us. The other 85% would be invisible. This invisible mass has been named cold dark matter. Matter because it's physical stuff, cold because it's moving at slow speeds, and dark because it's invisible. Now, when I say it's invisible, I'm not saying we can't detect it because it's too small or too dark to see. No, it's invisible in its very essence. It emits no visible light, no X-rays, no radio waves, nothing. Nor does it absorb any light or reflect any light. In fact, it doesn't interact with light at all. That's why it's invisible, because light and all other forms of radiation would pass completely through it. This is only one possible explanation, though. There are several other explanations, some of which don't even require there to be any missing mass at all. They account for the observations in other ways. But most secular astronomers reject all these other possibilities. Why? Because they don't fit the Big Bang model. So, because most secular astronomers believe in the Big Bang, they must believe that the missing mass is made up of cold dark matter, an exotic new form of matter that's not made up of atoms, but some other particles that are invisible. Matter like this would be outside of known physics. That's why you'll see astronomers frequently make comments like this one. What exactly is it? What is it made from? Well, the simple answer is, we don't know. No known particle fits the description. And as a Princeton cosmologist has commented, it's an embarrassment that the dominant forms of matter in the universe are hypothetical. Even though there are no good theoretical candidates for dark matter particles, many physicists have been looking for them anyway. So far, the searches have been unsuccessful. But let's say that someday, researchers actually found a new particle that meets this description. Would that support the Big Bang model and discredit the creation model? No, it wouldn't. If new forms of matter were found, the current Big Bang model would need to be modified to account for them. If cold dark matter were discovered, and if it turned out to be the explanation for the missing mass, this wouldn't be a triumph for the Big Bang model. Instead, it would require yet another modification of the Big Bang model. Yet another bandage slapped onto a theory that has already accumulated a pile of them. Remember, the Big Bang was supposed to have created all the matter in the universe, and this would include dark matter, if it exists. However, the current Big Bang model was set up to explain only normal matter. It has no explanation for this mysterious stuff that's supposed to make up 85% of the mass of the universe. As one astrophysicist explained, really, we have no idea what's causing it. We so don't know what's causing it that we shouldn't even call it dark matter, because that implies we have some understanding that it's matter. We don't know what it is. I could call it Fred. 85% of all the gravity in the universe comes from something about which we know nothing. Let me rephrase that last sentence. 85% of all the gravity in the universe comes from something about which the Big Bang model knows nothing. Along with dark matter, there's more in the universe about which the Big Bang model knows nothing. A lot more, in fact. In the late 1990s, astronomers were studying some faraway supernovae. Supernovae are enormous explosions in space that occur under certain circumstances. For example, if a white dwarf star pulls material off of a companion star, it can only do this until a critical threshold is reached. At that point, the white dwarf quickly explodes in a massive, violent catastrophe. Anyway, astronomers were studying these supernovae, and they discovered something unexpected. The astronomers calculated the distance of the supernovae by measuring the brightness of the explosions. Then they calculated the distance that the Big Bang model predicted based on the redshifts, and the distances were slightly different. What does this mean? Well, according to the Big Bang model, this means that not only is the universe expanding, but the expansion rate is also accelerating. In other words, it's not only getting bigger, it's getting bigger faster and faster. According to the Big Bang model, all of the space in the universe must be filled with some kind of anti-gravity energy, driving the universe into expanding faster and faster, even though mutual gravitation among all the galaxies would otherwise prevent this. The Big Bang model requires a tremendous amount of this energy, filling the entire universe, and growing as the universe itself expands. So what is this mysterious anti-gravity energy that the Big Bang model requires? It's become known as dark energy, not because it's something that looks dark, but because it's similar in some ways to the concept of dark matter. Just like dark matter, it's outside of known physics. Nobody has ever seen any, and nobody has any idea of what it could possibly be. Earlier we saw that secular cosmologists believe that 85% of the physical stuff in the universe is invisible cold dark matter. But this invisible dark energy would be about twice as abundant as all the physical mass is, about 68% of the total mass energy of the universe. As an article in Astronomy magazine explained, to get enough oomph, that's a technical cosmological term there, to drive the present acceleration of the universe, dark energy must make up about 68% of the total density of the universe. The biggest problem with this idea is that no one has any idea what dark energy is. So far, all we've been able to do is name it. So what exactly is dark energy? The obvious answer is, again, we don't know. Actually, the situation is even worse. We really don't know. Although cosmologists have adopted a cute name, dark energy, for whatever is driving this apparently anti-gravitational behavior on the part of the universe, nobody claims to understand why it is happening, or its implications for the future of the universe and of the life within it, despite thousands of learned papers, scores of conferences, and millions of dollars worth of telescope time. The nature of dark energy is now perhaps the most profound mystery in cosmology and astrophysics, and it may remain forever so. Let me repeat, we don't actually observe any dark energy in the cosmos. The only things we observe here are the brightness of the supernova explosions as seen from Earth, and the redshifts that we measure in the light. So dark energy is not something that's observed. It's just an interpretation of the observations that's required by the Big Bang model. So once again, the Big Bang model requires something that is completely outside of known physics. In this case, anti-gravity energy. And once again, the Big Bang model has no explanation for what it is or how it formed. So let's review. There's a lot of stuff in the universe that we can see: planets, stars, galaxies. However, there might be some mass out there that we can't see. Most astronomers believe that this is made up of mysterious dark matter, some new form of invisible non-atomic matter that's almost 6 times as abundant as the matter we can see. And then there were some supernova observations. If you interpret them according to the Big Bang model, they would indicate that there's this mysterious anti-gravity stuff called dark energy that's more than twice as abundant as the matter is. In other words, everything we can see in the universe, its planets, stars, and galaxies, only make up between 4 to 5% of the universe. Dark matter, which the Big Bang model requires but doesn't explain, makes up about 27%. And dark energy, which again the Big Bang model requires but doesn't explain, makes up about 68%. Now the Big Bang was supposed to explain where the universe came from. In other words, it was supposed to explain the origin of everything. But here we see that the model doesn't actually explain everything. Even if it were good science, which it's not, it would still explain only 5% of everything. So if your theory of everything only attempts to explain 4 or 5% of everything, do you really have a theory of everything? I think the answer is clear. Even many secular scientists are unhappy with the situation. As one astrophysicist has complained, it really is strange, and to our perhaps uneducated eyes, arbitrary, ugly, or accidental. To live in a universe where only 4% of matter is ordinary matter, I find awkward at best, implausible at the least, but there it is. If I didn't have all these facts in front of me, and you came up with a universe like that, I'd either ask what you've been smoking, or tell you to stop telling fairy tales. Despite all of the problems with the Big Bang model, most secular cosmologists still insist that there's strong evidence for it, so it must be true. Let's talk about that for just a moment. As we saw earlier, there are three primary lines of evidence that are claimed to support the Big Bang: redshifts of distant objects, the abundance of light elements, and the CMB, or cosmic microwave background. Redshifts are indeed consistent with the Big Bang model, but they're also consistent with other cosmological models too, so they don't require the Big Bang to be true. As for the close match between the Big Bang model and the observed abundance of light elements, this too isn't as impressive as cosmologists claim. First of all, this wasn't a prediction made ahead of time. The abundances were already known when the Big Bang model was being developed, so the model was just tweaked to match them. Second, it also turns out that even after this tweaking, there are still some discrepancies between the predictions and the actual observations. And third, just like redshifts, the abundances are consistent with other cosmologies besides the Big Bang anyway, so light element abundances aren't very persuasive evidence for the Big Bang model after all. But what about the CMB, the cosmic microwave background radiation? What about this discovery that supposedly proves the Big Bang model is true? As we saw earlier, the CMB was the crowning glory for the Big Bang model. The CMB's existence is the one major prediction that the model seemed to make successfully. But unfortunately for secular cosmologists, the more we've learned about the CMB, the more trouble it's caused for their model. As this video is being made, the best measurements of the CMB have come from the Planck spacecraft. Planck has verified what previous studies had already found, that there's a large-scale pattern of temperature differences in the CMB that the Big Bang model can't accommodate. We've already discussed how the temperature differences between any 2 points in the sky is very small, which causes enormous trouble for the Big Bang model. But it also turns out that these small temperature differences are arranged in an overall pattern that the Big Bang model can't explain. This pattern is called the axis of evil, which tells you how secular astronomers feel about it. They don't like it because it discredits their ideas about the Big Bang model. As one author commented, the apparent alignment in the cosmic microwave background in one particular direction through space is called evil because it undermines our ideas about the standard cosmological model. Along with the axis of evil, Planck also showed a large cold spot in the CMB. Again, this doesn't match the Big Bang model. And as if this weren't enough, cosmologists have recently realized that the Planck data have discredited a lot of their ideas about inflation. As these astrophysicists noted, thanks to the Planck mission, the Big Bang's inflationary paradigm is now in trouble. The models most favored by their data, combined with earlier results, suffer from exacerbated forms of initial conditions and multiverse problems, and they create a new difficulty that we call the inflationary unlikeliness problem. That is, the favored inflaton potentials are exponentially unlikely, according to the logic of the inflationary paradigm itself. The unlikeliness problem arises even if we assume ideal initial conditions for beginning inflation, ignore the lack of predictive power stemming from eternal inflation and the multiverse, and make no comparison with alternatives. Thus, the three problems are all independent, all emerge as a result of the data, and all point to the inflationary paradigm encountering troubles that it did not have before. Remember, inflation is necessary to solve three problems that would otherwise be fatal for the idea of a Big Bang. We already discussed that inflation isn't a valid solution anyway. But even if you set that aside, new observations of the CMB make inflation look extremely unlikely, which means it's extremely likely that the Big Bang model has those original fatal problems again. By this point in the video, you might be wondering about something. You've probably been told that secular cosmologists have lots of evidence for the Big Bang, and that all competent scientists believe the model. But if, as we've seen in this video, the Big Bang model really fails so badly, then why do all the scientists believe in it? Well, the answer is that all the scientists don't believe in it. There are many scientists who are Bible-believing Christians who obviously don't accept the Big Bang, nor should they. But there are also many secular scientists who reject the Big Bang model. To be clear, these scientists are in the minority. Among secular astronomers, the Big Bang model is still the majority view. But that doesn't mean the model is correct. Science is not politics, and truth is not determined by which idea gets the most votes. Meanwhile, even many non-Christian astrophysicists understand that the Big Bang model has failed. As one wrote, "To explain some surprising observations, theoreticians have had to create heroic and yet insubstantial notions, such as dark matter and dark energy, which supposedly overwhelm, by 100 to 1, the stuff of the universe we can directly detect. Outsiders are bound to ask whether they should be more impressed by the new observations or more dismayed by the theoretical genies that have been conjured up to account for them. Modern cosmology has, at best, very flimsy observational support. In its original form, an expanding Einstein model had an attractive economic elegance. Alas, it has since run into serious difficulties, which have been cured only by sticking on some ugly bandages. Inflation to cover horizon and flatness problems, overwhelming amounts of dark matter to provide internal structure, and dark energy, whatever that may be, to explain the seemingly recent acceleration. A skeptic is entitled to feel that a negative significance, after so much time, effort, and trimming, is nothing more than one would expect of a folk tale, constantly re-edited to fit inconvenient new observations. And as other authors have said, the whole thing has the feeling of something held together with a band-aid. If it hadn't been for the addition of the idea of inflation, the whole concept wouldn't work. And the trouble with inflation is that although it's something that would make what's observable possible, no one can come up with a decent explanation as to why it should have happened. Look at the facts, says Ricardo Scarpa of the European Southern Observatory in Santiago, Chile. The basic Big Bang model fails to predict what we observe in the universe in three major ways: the temperature of today's universe, the expansion of the cosmos, and even the presence of galaxies have all had cosmologists scrambling for fixes. Every time the basic Big Bang model has failed to predict what we see, the solution has been to bolt on something new: inflation, dark matter, and dark energy, Scarpa says. Today's standard model of cosmology has become an ugly mishmash comprising the basic Big Bang theory, inflation, and a generous helping of dark matter and dark energy. Big Bang theory relies on a growing number of hypothetical entities, things that we have never observed. Inflation, dark matter, and dark energy are the most prominent. Without them, there would be fatal contradictions between the observations made by astronomers and the predictions of the Big Bang theory. In no other field of physics would this continual recourse to new hypothetical objects be accepted as a way of bridging the gap between theory and observation. But the Big Bang theory can't survive without these fudge factors. We see then that even many secular scientists recognize that the Big Bang model is a folktale, an ugly mishmash of discredited ideas and bandages meant to rescue the theory from the facts. And as we'll see next, that ugly mishmash is about to get far uglier. The Big Bang model is supposed to explain how the universe got here without any sort of intelligent creator being involved. Supposedly, the universe just happened. If that were true, then you'd expect the universe to look like the outcome of random natural processes. You wouldn't expect the universe to look extremely fine-tuned, but that's exactly what we see. Now, entire books have been written on how well-designed and fine-tuned the Earth is to support life. Some of these are even from secular authors. In the previous video in this series, we also talked about how well-designed the sun is too, and how none of this should surprise us, because the Bible says that the Lord created this world for us to live here. Secular astronomers, though, have no explanation for this. All they can say is that if the Earth weren't a suitable home, we wouldn't be here to observe it. Obviously, this isn't a very satisfactory explanation. It turns out, though, that this problem is bigger than the Earth and Sun. Far bigger, in fact. The entire universe appears to be fine-tuned for us to be here. This extends beyond objects like planets and stars, into the very fundamentals of physics itself. Many of the laws, forces, and constants of physics have very fine-tuned values. If you change them even slightly, the universe would be vastly different, and we wouldn't be here to observe it. As famed cosmologist and atheist Stephen Hawking has written, a change of as little as 0.5% in the strength of the strong nuclear force, or 4% in the electric force, would destroy either nearly all carbon or all oxygen in every star, and hence the possibility of life as we know it. Change those rules of our universe just a bit, and the conditions for our existence disappear. Most of the fundamental constants in our theories appear fine-tuned, in the sense that if they were altered by only modest amounts, the universe would be qualitatively different, and in many cases, unsuitable for the development of life. For example, if protons were 0.2% heavier, they would decay into neutrons, destabilizing atoms. Our universe and its laws appear to have a design that both is tailor-made to support us, and, if we are to exist, leaves little room for alteration. That is not easily explained, and raises the natural question of why it is that way. Many other scientists agree with this. There is now broad agreement among physicists and cosmologists that the universe is in several respects fine-tuned for life. It is fine-tuned for the essential building blocks and environments that life requires. This fine-tuning extends even to the features of individual atoms. As astrophysicist Sir Fred Hoyle, who is not sympathetic to creationism, wrote, "Some supercalculating intellect must have designed the properties of the carbon atom. Otherwise, the chance of my finding such an atom through the blind forces of nature would be utterly minuscule." A common sense interpretation of the facts suggests that a super-intellect has monkeyed with physics, as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. Now, to be clear, many of these fine-tuning arguments are based on the Big Bang model. Obviously, I don't accept the Big Bang. But it's fascinating that the Lord created the universe in such a way that even a theory designed to deny His creation still makes the universe look designed and extremely fine-tuned. As one physicist wrote, "Life appears to depend upon delicate coincidences that we haven't been able to explain." Another said, "Our own universe is an extraordinary place that appears to be fantastically well designed for our own existence. This specialness is not something that we can attribute to lucky accidents, which is far too unlikely. The apparent coincidences cry out for an explanation." Years ago, some scientists attempted to calculate how finely tuned the Big